So, yes, sir.
Do we have school on Friday?
No, someone's messing around. You can erase that for me. Guys, hey, what's up?
You know the game that was recorded at the end of Space Jam?
It's been a long time since I've seen Space Jam, but I'll go ahead and say sure.
Yeah.
Yeah.
My grandparents told me they were on that game.
She what?
My grandparents told me they were on that game.
That's awesome.
Yeah.
All right, so let's talk about progressions. When we're dealing with progressions of the, what do you call them? Parallel lines and transversals. What I need to introduce you guys to is this way of writing something out. I don't know about you, but I sure don't want to write this out every time. Don't write this. If two parallel lines are cut by a transversal, that basically everything we're talking about today has that built into it, but we don't ever say that. We don't write that down. I came up with a symbol to show that what this means. It's this. If two parallel lines are cut by a transversal, and yes, you have to use the arrows. Because if you don't have arrows on it, what does it look like?
It just looks like an equal sign.
It looks like a not equal sign.
Yeah.
Okay? So whenever we have parallel lines, you know how we always throw that there's arrows in there? So that's why I do it this way. So what we're going to do with the progressions for this is the following. I want you guys to put in there, if two parallel lines are cut by a transversal,
Two parallel lines.
then you can put it on any one of them. We're going to put this in one of them, and then we're going to put some others in another one here in a second. So yesterday, when we had two parallel lines cut by a transversal, we were then able to say four separate things. The first thing we said was alternate interior angles are congruent. Right? Yeah. Or alternate exterior angles are congruent. Where's your progression sheet?
I haven't had one for.
Well, go get a blank one and start over. That's what they're there for. Or corresponding angles are congruent. Or consecutive interior angles are supplementary. So all four of those can be thrown into one single progression square because there's no reason for us to continually write them out. And I'll show you guys in a second here what it's going to look like in a proof. I don't want to say that there's a magic bullet for how it's going to look in every single proof, but generally speaking, it's a very, very, very simple scenario. Okay. Now, yesterday when we introduced all the different angle pair relationships, I kept asking you guys, hey, what are angles 1 and 3? What angle pair are they? So you guys were having a bit of a hard time remembering what each one of these looked like. So what I want to do is take the next two squares and put in examples of what alternate interior, what are alternate exterior. Write out that shorthand lingo that we did, same side inside, same side outside, things like that. I want to put that down on paper so that you never forget them. Because am I going to take this away from you this week? No. It's up to you to have it. It's up to you to have them going through, okay? Excuse me. So, in your next square, let's do this. Alternate interior angles congruent, and let's draw an example. Straight. And then just mark the diagram of where are your alternate interior angles. Like that. Or I'll grab that on the other side. Is there a red one right there? Can you throw me in this? Thank you. And then we would just mark them, okay? And then on the side here, write down, remember that shorthand we talked about yesterday? Opposite sides on the inside. Oops, can't spell inside. That way you have an example of what it looks like. We have an example of what it looks like, we should never forget what it looks like, okay? I hope. And then below that, we'll do alternate exterior.
Let me draw this big all big and they gonna say something below next to.
I learned from last time.
I thought I said we are gonna put two of them on one.
Nope.
It doesn't matter, you guys can put them all in their own separate one if you want, it doesn't matter to me. I just thought it was easier to save space, that's all.
Hey, it's mine.
Oh, cool.
And these are opposite sides. Okay? So we have alternate interior, alternate exterior. Alternate interior are same side on the, or excuse, opposite sides on the inside. Alternate exterior are opposite sides on the outsides. Okay? I just want to make sure you guys had a picture of it, so that way when we go through and we look at an actual example of this, it's not so bad. Okay? Also, I want to remind you guys at the end of the hour today to take a picture of your progression sheets. I had a student in first hour who lost hers, and she did not have a backup file of it. Uh-huh.
Wait, I think I said something wrong.
Oh, yeah, I did. Sorry about that. Thank you. Thank you, thank you. Sorry about that, guys. There, is that better? All right. So, come on, guys. We don't have that much to look at. Let's do the other one.
Laura, put you two in here.
14 of my fish died today.
I'm sorry to hear about your fish.
Why do you kill fish?
I hope my beta fish doesn't die.
Rest in peace, fish.
Because she
Wait,
kept
did you guys have
it
to
in the
buy
cabinet. It's in the cabinet in the classroom right now.
Yeah.
You have to buy them.
We bought 20 fish for our
Yeah,
biology
did
project.
he?
You know, to keep them alive. And Hannah brought them to her house Sunday night, and the next day, 12 of them are dead. And today, we came there, and there were like 4 of them dead.
Wait, what y'all talking about?
Wake up, Mr.
Anyway. Corresponding.
Oh my god, what
My partner did.
I just see that tornado.
I know, she just kept them in the background for 2 days.
Oh yeah, the dog.
Again, ladies and gentlemen, corresponding angles. Corresponding angles are same spot, same position. Let me rephrase that. Same side, same position.
Move like a dot to dot.
Yeah.
I want to double.
So with corresponding angles, there are 4 sets of corresponding angles. Okay. The other ones are always 2 sets. There's 2 sets of alternate interior, alternate exterior, and there's going to be 2 sets of consecutive interior. The corresponding, there are 4 different ones. This
What
one,
are the like 2 little D things on the
the parallel.
side? Okay.
Those are arrows. Remember?
Oh.
Those are my arrows.
The other arrows.
I thought that was a D.
Aren't you supposed to add them?
Why do you do your arrows
What's up?
that way?
Aren't you supposed to add them? The arrows?
Usually in the diagrams, see how they just have that little single arrow? That's how they do it.
No, I'm talking about the arrows for the line.
Oh, since these are small diagrams, I didn't want to get too messy with it. Okay. And then, so we called these same side, same position. Okay. So the corresponding with the same side, same position. There are 4 sets of those. Remember, we had like top left, top right, bottom left, bottom right, things like that. And then the last one was the consecutive interior. Consecutive interior are same side, inside. Consecutive interior. It's abbreviating. Yeah. So consecutive interior, same side, inside. Hey, is there any such thing as a consecutive exterior?
No.
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 Because if it was, you would have put it on there.
It's like a
Ding, 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 ding,
unicorn.
ding, ding, ding. Yes, ma'am.
So on the test, are you just gonna give us like diagrams or just gonna have to name?
It depends on the problem. I'm going to show you a second here what a proof is going to look like with it, because a lot of times when you, hey guys, this is a really good question here, because a lot of times when you have a proof, you're going to be given the parallel, and then you're going to have to figure out what angle pair relationship it is to say that they're congruent. That's where this goes to. Okay. What was it, Luke? You were saying something? We're going to do this again?
No, oh, I said I like do it. It's like, are we gonna do this again? Like,
I thought you were saying we're gonna do this again because we're doing proofs. Like, really? Again?
Are we?
So let's show you guys an example.
because said,
Let's do this proof, guys. Let me walk you through what one of the proofs is going to look like when you have parallels. Yeah, put this in your notes so you have space for it, okay?
Wait, put it in our.
Oh, this is, someone else asked about this earlier. This is not like if P then Q, if Q not P, that stuff. This just happens that they label it line P, line Q, line R. That's all it was, all right? That's all it is.
not B and B not Q
Okay.
and F not
No worries about that. This is still green.
What's up? Take us here, man. Is it Reese? Are you sure?
All right, so here's what I want to do. When we are given stuff about parallel or given stuff about perpendicular, remember, you guys have progressions on there to tell you what to do. So draw up the diagram, write out your given and prove statement, and then we'll walk through this rather slowly.
Piece of paper is this.
Oh, you're gonna want to put this on your in your notes.
Did I mean parallel?
Yes, ma'am.
Do you want this on our proof sheet?
No, put it in your notes. This in your notes, okay?
Did it break?
Oh, this is B.
So what happens here is that the first thing you're given something about being perpendicular. Now, on your progression sheet, you have information that tells you what to do if you're given perpendicular. I believe it says the very first thing to do is what?
State all the right angles.
Very good. So if line P is perpendicular to line Q, are there any other letters besides just line P, line Q? Is there an A, B, C, X, Y, Z, or anything like that? Bless you.
Yeah, what is that?
Just means they're parallel. There are no letters to tell you, there's no capital letters to tell you about the angles themselves here. But there are numbers. If line P is if line P is perpendicular to line Q, which angle is a right angle? 1. So according to my progression sheet, it says state the right angles that are formed. Well, angle 1 is a right angle. What do you think the reason is? What did we just use? Oh, oh, oh. That thing. What does it say? What does it say in your sheet after you talk about this? What do you put there? Definition. Should be on your sheet, guys. If you're given perpendicular, you're using perpendicular. I know I can do both this fork thing all day. I can't say the word perpendicular. All right. Now, the second part on perpendicular said to state the right angles are congruent to each other. In this case, it doesn't have any other right angle here. It just happened to be one spot because they're only looking at the intersection of those two parts. There's nothing else that I can do with this given statement.
Wait, but would it?
We don't know this yet. We don't know this yet. Because with our second given, it says P is parallel, or not P, Q is parallel to R. So if Q is parallel to R, now there's something that I can do. Whenever I'm given parallel, think about what we just did with our progression. If two parallel lines are cut by a transversal, two parallel lines, we have a transversal, you had 4 different angle pair relationships that occurred. What's the angle pair relationship now between angle 1 and angle 2? They're corresponding. What do you know about corresponding angles? They're congruent. Very good. So now that I have this, I can say that angle 1 is congruent to angle 2, and this is the reason, right off the progression sheet. If two parallel lines cut by a transversal, corresponding angles are congruent. Sure.
I mean, we're not just taking notes. Is the test tomorrow?
Sure.
Oh my god, you guys.
Okay, what about?
What? My mom has
Test
to
two
say this
Friday.
tomorrow.
It says test 2 Friday.
It says test
Okay,
to Friday.
then I need to yell at my mom.
My mom got the same email as said Friday.
Yeah.
Wow. Do you think I emailed everybody at the same time?
Yeah.
Did you guys know that I emailed you as well?
Yeah, I did know that.
Wait,
What's about this test in math?
I get the good morning geometry.
yeah. Did you have a good weekend?
I did.
So, hey, you can't fault me for trying to be communicating with people. I try to at least tell you what the heck is going on.
cares.
Our other teachers just say, here.
We should also I'm hungry.
Can I respond? I had a good weekend.
All right.
When I did that
So take a look at what we know. Take a look at what we know here. We know, if I look at this, I know that angle 1 is a right angle, and angle 1 is congruent to angle 2. So what can I say about angle 2? Why?
Because it's congruent to angle 1.
I'm putting something in for something else. It's called
Substitution.
Substitution. Got it.
Got it.
Hey.
What is up with everybody copying each other?
So now have we shown that line P is perpendicular to line R? Because we have a right angle now. So by the definition of perpendicular, those two are perpendicular. So I can say P because the definition of perpendicular says that you have right angles that are formed. That's how these types of angles or these types of proofs are going to work when you've got parallel lines. It's really a matter of identifying the angle pair relationship and writing it down. That's it. And you now, on your sheets, all have an example of what every single one of them looks like. There should be no making up of stuff. You have to be able to read. Look at your diagrams, okay? That's where this comes from, all right? Does that make sense of where this is going to go? Yes, ma'am. Help yourself. I got it back. I got another example to give you guys here before I give you the 4 problems I have for you from homework.
What is that on? Oh, he's saying comedy starts on the It's 13 comedy, so 13 minus 3.
Come on, guys.
Well, thank you.
All right.
I'm gonna be at NIU.
What's that?
I'm gonna be at NIU. So
Why? What do you guys got? No offense, but
yeah, we're not having that here.
I want to watch that now.
so
Oh, we're supposed to buy this backwards.
Well, it came from so we're also the guard.
Hold on, let me do this one. I can get through a lot more if you guys stop talking. Okay? So I'm going to start with number 1. And a lot of times with these types of problems with parallels, it's going to be multiple lines. They're going to show multiple lines as you're walking through it. And they give you that A is parallel to B, so this is line A, B, C, and D. They say that lines A and B are parallel, and lines C and D are parallel. So I'm throwing my arrows in there to show that they're parallel. And you want to prove that angles 1 and 3, or 1 and 13, excuse me, so here's how you start something like this. Again, you start with the idea of your given. A is parallel to B. Given. Knowing that I'm going to have, well, in this case, it's a matter of fill in the blank. So you have A is parallel to B, and C is parallel to D. So look at your angle pairs now. Why is 1 congruent to 12? Mark your diagram. Yes, sir?
Nothing.
I know it. Corresponding angle. No, it's
What's your
alternate
progression?
exterior angles.
Yeah.
They're alternate exterior, but what do I have to write? Yep.
How do you say that again?
If 2 parallel lines are cut by a transversal, then
I just said they're alternate exterior.
alternate exterior angles. You're right. What's up?
Can you write that all? Oh yeah.
You can write that.
2 parallel lines, arrows, arrows, and arrows. That's all that symbol is. That's all that is. Yes, ma'am. Yeah. Angle 1 is congruent to angle 12 because if 2 parallel lines are cut by a transversal, I don't want to write all that out, that takes forever, then alternate exterior angles congruent. Yes, ma'am. That's all it was showing there. I'm trying to shorthand some of the length, the verbiage on it, just because why get lost in writing out all the words? Use symbols and abbreviations. And the way that I've abbreviated is as broke down as I can think of to do it. Okay? So now I look at the next one. Angles 12 and 13 are congruent to one another, so I look at the diagram. What's the angle pair relationship between 12 and 13? Alternate interior. So my reason,
If
The little thing.
if the little thing, yes.
the parallels have a transversal.
Oh,
that's how you do it?
Yeah.
interior.
That's all it is. See how you're using that one progression box
Wait, how do you say this one?
for your reasons. You're given parallel, so if 2 parallel lines are cut by a transversal, then one of those 4 angle pairs happen. You just have to decide which one it is. The first step with 1 and 12, they were exterior. The angles with 12 and 13, they're interior. Now notice what we have in terms of 1 is congruent to 12, 12 is congruent to 13. What do I know about 1 and 13?
But they're congruent.
They're congruent to each other. Is it substitution or is it transitive? This is a transitive example. And I want you guys to pay attention to how transitive works again. Transitive is always on a diagonal.
This is transitive prop.
Is
I mean, not.
substitution wrong or is transitive more right?
Transitive is more right.
Transitive is more right. So, real fast then, do this. Transitive,
Is your right?
yep, versus substitution. I had to save a couple for my other classes. I had to count through what I have right now, okay? So what I need you guys to do is I want to make sure we have an example on our progression sheet so that way we don't make a silly mistake about the difference between transitive and substitution. Because if we have this information on there, you're going to be hard pressed to screw it up. So transitive property. Transitive property is always the A equals B, B equals C, A equals C. Remember, it's always on the diagonal. When I do substitution, X equals Y, Z equals Y, X equals Z. Notice how the Y's are above one another. That's what substitution looks like.
How would that be like,
Just like the one we just did. You know how we said 1 is 12, 12 is 13, 1 is 13? That's a transitive property.
oh, is it the whole part?
Yeah. Whereas if you had it as 1 is 12, 13 is 12, 1 is 13 because of substitution. So it just depends on how it's written out and how you decide to write it out. Okay?
Wait, so let's, well then isn't that?
It depends on if it's given to you like that or if you're, it really depends on the problem. But that's the difference here. What I want you guys to do on these are 2, 3, 4, and 5, please. 2, 3, 4, 5. There are a couple more fill in the blanks, and then the ones in the back are really short on your own proof. Okay. 2, 3, 4, and 5 on this one. I will give you a hint on number 2. One's given, obviously. 2 is definition linear pair. Yes, ma'am.
Oh yeah.
Congratulations. Why? Why is your cat here?
That's what I was thinking about saying.
Wait. Well, I mean, I know you're a little weird. I know your cat.
Did she?
All right. Go through those 4. The first 2 are all fill in the blank. The last bit are very easy on your own. Tomorrow what we'll do is we'll talk a little bit more about why certain things work, why you can prove lines are parallel, and start doing a little bit of the review from some of the old proof stuff, okay? To be honest with you, I think we could probably go on Thursday, but I don't know. There's no rush. It'd be easier to do it Friday. I got more time to grade them. Yes, sir.
Okay, so back to the conversation we had. Okay, I see what you're saying. You'd rather get the money, but say it was the other way around, and it was you knew that you didn't know that they were both watchers, but you were there, like for game 5 or 6.
Yeah.
Would you go?
Would I go? It would be a difficult decision. It depends on how many tickets I had. If I could leave my wife at home and then take and sell and get $6,000, I think my wife would be okay with that. If we had 4 tickets and I would just go by myself, or myself and my wife would sell the other 2 and leave my children at home, I would do that. It really depends. I had a situation. Oh, geez, I think it was last year.